Hi, I'm Vladislav Spirkov, and this is my presentation on sharding. So, what is it? What is a quick overview of sharding? Sharding is the idea of having horizontally scalable databases or servers. So the difference between conventional servers is that they're vertically scalable, which means you have one server that keeps getting bigger and bigger and bigger and more complex. While on the other hand, sharding is a technique that allows for many servers scaled horizontally and allowing for lots of data sets or databases spread out on many sort of servers or databases on their own. Um, this allows for limiting access, therefore allowing certain users or employees to only have access to certain little bits of these databases, while vertical ones require like more complex systems to be able to only limit certain parts of that one server. And finally, these databases sizes are much smaller, as previously mentioned, and you're able to organize them much better, as you can have, based on certain geographical locations, certain databases in certain areas, or based on any types of time series or race of customer or class of customer, and yeah. So, oops. Now I'm going to get into some advantages and disadvantages of them. So, as previously stated, they improve database, or sorry, as previously stated, they're a collection of smaller databases, which allows for improved database processing, meaning it would take faster to process these little databases. You can do more complex sort of techniques which would require lots of processing power on large servers. While since these are small, you can spend a lot less on powerful machines. You can replicate certain databases to create reading performance much quicker. So you can, have a copy of a certain database or set on your local machine and just load it from there instead of having to like download or upload from the cloud every single time. Again, organization is a lot easier because you can organize it and allocate each database to a given set of parameters. For example, as previously stated, age of customer or class of customer, race, geographic location within like the country. Um, this is additionally these are these databases are more user friendly from a professional point of view. Therefore, companies can like as can basically organize them better and just understand what data is on which database and how and who gets to access what, and it's just much easier to organize it. And finally, spread data geographically means that you can have many servers around the world, meaning different people from different geographical locations will still have good connection with low latency to the server or to the database that they need to access, whereas vertically scaled databases or servers require one geographical location, and people from the other side of the world might not be able to connect to them or download from them or upload to them as efficiently as spread data in a horizontal fashion. Some disadvantages are is that there is a possibility of single point failure, which means that if a certain database was to fail, it's still that geographical location or everyone that requires that specific database no longer has access to it. Therefore, it struggles on this horizontal scalability struggles on its own, or sharding struggles on its own. Additionally, you need multiple copies and complex backup procedures. So instead of only having one copy of 100 shards, you'll need like three copies of 100 shards, right? And that the more shards you have, it kind of like exponentially increases the complexity of like these security and backup measures. Finally, you'll also require some additional software just to maintain the organization of all these separate shards. Um, because to do it manual or not to do it manual, obviously, but like to have it done with like sort of in a manual fashion in the sense that like you don't have any specific software created for it, would just make it fish like reduce efficiency. So much more, or not much more, but it's a bit more investing in like specific softwares is required to organize it. This is a little bit about history. This is the earliest uh, sort of record of these servers that I could find. So basically, at the top, there's just a bit you can read it on your own time. There's a little paragraph of what this person's doing. He explained that he had two database. The initial problem is he had two database servers named Godzilla and Mothra, and their initial idea was to have more database boxes on these very expensive sum boxes that handle different parts of the website. The problem is that any MySQL instance would crash using, you know, this method, and the entire site would went down. Next, this person, Dathan Patishal, came up with an idea to have or have an ACP in a box, which means just having many inexpensive Linux boxes spread out, geographically or just spread out in this sharding fashion. These are some advantages. If only one box went down, only a small population would be affected. The application can query faster because there's less data. It could run more updates since it would have multiple write points. And the application can launch functions faster since the backend could support many more instances. What this means is many people can access the same shard efficiently. And these initial advantages are kind of like what the advantages are right now. So this person really came up with a good idea and kind of set in stone on how sharding and these horizontally scalable servers are really important to us. And the next application is in terms of a massively multiplayer online video game. This is taken from an article, Database Sharding Came from UO by Raf Koster. Essentially, for a massively multiplayer online video game, you need that's on a global scale. You want everyone in the world to play together. And they came up with this idea as database partitioning of worlds, parallel worlds, each running in the same static template database source, but involving different runtime databases. But these were just called servers. Um, and the next one is they start in the next quote. They started talking about shards. Um, these idea of shards where they're like just thinking of these servers as different shards of a database, and this is how like you could have the same sort of idea in a different non-data science related application. And that's pretty much it. Thank you for watching. Oh, sorry, my bad, I forgot I also had examples. um, so from some examples is Apache HBase, which has this idea of automated sharding, which allows people to, or allows company to, you know, turn their sort of databases into an automated system. Azure offers sharding tools for application-based environment. This I mentioned earlier about like user-friendly in terms of like from a commercial side of view. Extreme Scale is a NoSQL parallel processing service. MongoDB is also a NoSQL service. With horizontally scalable servers. And Spanner is Google's global scale database sort of system where it's obviously around the globe, therefore they require this idea of sharding for it to be run. And finally, I have my references, and that's it. Thank you for watching.